Hi, my name is Sumit Mohanty, and I'm going to talk about Ambari today. So I'm with Hortonworks, a committer on the Ambari project, so Apache Ambari project. So basically, it's an Apache project like pretty much everything that we do. And so there are essentially two goals as far as the Ambari project goes. So of course, one is provide an infrastructure that allows you to manage a Hadoop stack installation, and then plus try to make the whole infrastructure as extensible as possible, which is kind of straightforward in the sense that, as you can see, there are so many different pieces of a stack that you have to add. So that means it's almost a requirement that you must be extensible so that you can add new pieces together. So those are the two goals, and in my talk today, I'm also going to spend a good amount of time talking about what are the different capabilities that we have added for extensibility. So we'll go over that. So last year, December, this project went TLP, and these are a couple of the releases that we had before that, and then so far as Apache Ambari goes, we have been managed to release pretty often. So essentially, any feature that gets added, we try as hard as possible to essentially release it within a month or two at most. So let me dive a little bit into the architecture. So fairly straightforward design, as you can imagine, from a management infrastructure standpoint. So at the middle, there is a server that essentially is the brain behind how to handle the management operations. So there are a bunch of agents that are running on individual hosts, which actually do the work. So the agent basically encapsulates the platform-specific details or whatever you need to install stuff or configure some file, etc. So all of those details go into the agent. And on the top that you can see is basically your web interface. The web interface talks to the Ambari server purely using the REST API. Because going back to the extensibility assumption, essentially the REST API should have all the capabilities. So anything can plug into the REST API. So the Ambari web is actually no different than anything else that can potentially plug into the REST API interface. So going a little bit deeper into the server, so as you can see, it's basically a box with a lot of extension points on the side. So starting from the top, you have the REST API interface, and then there is a series of stack definition that are basically put in a declarative fashion as files into the Ambari server space. And then there is, of course, the database and the agents, etc. So there is one thing about the agent is that Ambari was using Puppet script till the release before last. So with the release 1.5.0, we completely switched to Python-based agents. So essentially, the agents are Python. The agents call into the application definition, which itself actually has a lot of embedded Python code. So essentially, moved to Python. But for now, both Puppet and Python coexist. But the general idea was to go Python all the way. And then, of course, going to the other side, there are plugins for Ganglia, Nudge. No, not yet. So yeah, so this is a demo that essentially a 800 node cluster that we set up on GCE. So the demo is actually a recorded video, just so that there is more predictability in terms of access. But this is an 800 node cluster that has about 7 nodes for the masters, and then there are slave nodes around 780 or so. So this is the list of hosts, which is fairly long. But anyway, I mean, there are some capabilities that added to the UI where you can filter based on names. But what I was trying to show essentially there are 7 large nodes, and the rest of the nodes are slave nodes, which are basically relatively smaller node. So this is the dashboard of the cluster. Essentially just wanted to highlight a few of the pieces, which is just the number of nodes that are running. So we typically use a GCE-based installation for some of the performance test and tuning, etc. So in this demo, I'm showing a restart all feature. Essentially, we'll just restart all of the data nodes. So there is one capability that got added recently where if you want to restart a bunch of nodes or bunch of hosts for whatever reason, you can actually do them in a batched fashion. So in this case, I'm essentially starting 100 nodes at a time. Right now, the wait time is about 20 seconds in between, but of course, you can configure that as needed. And then you have a choice of choosing whether you want to restart only the nodes that do not have the right configuration. But I will get into that later. So essentially, you push your batch request to restart all of the nodes, and it will appear as kind of 1 of 8. So because there are 800 or so therefore there are 8 batches. So essentially, you can see them happening one after another in batches, so batches of 100. And if you go into the batch, you can actually cancel the ones that are coming later. Right now, we don't have the ability to cancel the one operation that is going now, but it should be something that we add sooner. So the idea is that on this particular cluster, you are essentially seeing the 800 data nodes going through a rolling restart one after another. So while that is happening, it will take like 20 seconds. So these are a couple of the admin features that kind of helping me shoe into another demo. But so there is the way you can enable high availability. There is a way you can enable security. And then you can also look into some static information, such as what version of the stack service is deployed, or what are the username, etc., that you selected for your deployment, etc. So now going back to the background operation, what you see here is the second batch that started up. And so now what you see is like batch number 1 is done, and then batch number 2 is done. And this restarts is obviously fairly straightforward and fairly fast. So essentially it allows you to, so you make some configuration changes and you can slowly roll in the configuration changes as without actually affecting the full cluster, basically without stopping the full cluster. So that's essentially what is going on. Now, as you can see, while the restart was happening, of course, some of the hosts were showing alerts, which is kind of expected because the data node was going down and then coming up. And essentially, as you can see, the alert should actually come up and then slowly go away, because obviously when data node comes up, the nudges alert will actually shut it down, so the alert should go away. So you can go to the hosts page, and there are a couple of filtering capabilities that allows you to filter hosts based on whether you see any alert or any other filtering capabilities that you need. So that's really the demo, essentially focusing on somewhere to restart or somewhere to do bulk operations on the host. So that's essentially a new capability that we added. So another thing that I hinted at during the demo was the wizard. So for example, the HA wizard or a security wizard. So wizards, as you can expect, is kind of a mix of what I can say, something that you do manually and something that happens automatically. So essentially, that's why you see the wizard with many pages going one after another. So this is just a few screenshots of the wizard when I was actually enabling HA for name node on that same cluster. So in this case, it is essentially just showing the same cluster, but after HA is enabled on that particular on name node. So essentially, the admin page is saying, okay, your HA is enabled, so obviously you cannot re-enable it. And then as you can see, the only bit of different here is that you have the active name node, the secondary name node, the journal nodes are showing up, and then this is just a UI magic in the sense, if you click on journal node, you only see the hosts where journal node is actually implemented. And this is just the capability that where Ambari can point to the actual UIs if you jump in directly to the UI or monitoring UI or the JMX endpoint, etc., of individual services. So that's essentially the same 800 node cluster with HA enabled. And then later I have another demo to talk about configuration groups. So let me go into some of the aspects of Ambari. So the default stack, essentially, stack being the stack definition that actually holds all the definition of various services that constitute the stack. One thing that I wanted to point out here is basically the word default. So that means that you can actually define your own stack. You can actually add your service. You can remove your service. So you can just say that, yeah, okay, this is my stack, and my stack contains these services. And it could be any of the services here. It could be any services that you want to add on your own. And then we will go into what exactly you need to do if you want to add your own service. But this happens to be the default stack, and Taze, Falcon, and Storm happens to be the ones that got added in the current release of 1.50. Okay, so let's get into config management. I mean, at the level of config management, the problem is fairly straightforward, and we all know that. So essentially, you have configurations, and as we know, Hadoop actually has hundreds of configurations. So, and then you need to make changes to some configuration, or you need to add new configuration. So that's really the basic capability that you will expect from anywhere. So here is my configuration. I can change the value, and I can save my configuration. Or here is another name value pair that we have no idea, but it got introduced in the new release. So you can obviously add any arbitrary name value pair as long as you know how it works through Ambari as well. So that's really the basic. Then comes the next level, which is something, several of the talks have talked about heterogeneous clusters. Because you obviously cannot always, if your cluster is long living and then you have it for like years, obviously the hardware across the cluster cannot be guaranteed to be heterogeneous. So naturally, there is a requirement of different configuration to be applied at different hosts. So this host configuration group essentially is a ability for you to create subgroups of hosts on a per service basis. So that means you can pick HDFS, and then you can say, I have like 3 groups of hosts, maybe the oldest host or the new ones that I bought, or some really beefy host that I am dedicating for some purpose. So then what you're really doing is you're creating configuration groups, and then you're assigning hosts to the groups. And then now if you apply configuration, essentially you have deployed a heterogeneous configuration across the cluster. So that's really the host configuration group. So now that you had your regular configuration, you have your host group specific configuration. So what's next? Obviously you're going to apply the configuration. Now apply the configuration, fairly straightforward, but of course things may happen in a different fashion than you expect. So for example, maybe one host was not accessible, so obviously the configuration didn't get applied. Maybe you actually changed a single host group, so obviously you don't want to apply configuration to all the hosts in your cluster. I mean, in this case, it was 800. So then you have a way to apply the configuration in a stage fashion. And then similarly, what is happening here on the front end is that through the API, it can find out what are the hosts or what are the host component, as in which instance of the data node or which instance of the region server does not have the actual expected configuration. And all they are doing here is actually indicating that in the UI. It, of course, is a lot cooler to see in UI, but ultimately all of this comes from API. So any capability that you see here, APIs actually have that support. So in this particular demo, essentially, we'll just go through quickly a config group. So this is, again, same host. By default, we start with a group of all the 800 nodes that actually have the same configuration. And what I'm doing here is just creating a group just purely from an example basis, and then just call it HDFS2. And you can obviously add as many hosts as you want here. I'll just add one. And you just go in, you select the host, and then what happens after that is you basically have 2 configuration groups. One has 799 nodes, the other one has just 1. So now you can switch on to the configuration side, and then now you can edit either the group 1 or group 2. In this case, I'm editing group 2. So just some changes. As a change, it doesn't really matter, but something got changed, and then you save the configuration. What really went on in the back end is that that whole configuration got saved as a new version, and right now Ambari server knows of the new configuration. Now it also knows that because agents are reporting old configuration, they are not matching. So that's really what is going on. And then what we are seeing here is essentially that being displayed in a more human readable or more friendly way. And then there is a there is a little button that tells you, oh, okay, you want to restart these things? Okay, let's just restart the ones that actually have old configuration. And then that's what is going on here, and you have the same capability as before in terms of restart, but now it is filtered for the hosts that actually do not have the right configuration version. So now you issue a restart. Obviously, what happens after that is with some delay, that is because the agents actually heartbeat with the server, and the server then gets the version that is applied. So after some delay, what you will actually see is that now the Ambari server knows that this particular host or this particular agent is reporting the right configuration, and that indication will basically go away from HDFS because I didn't really change any other configuration. So that's really went on behind the scene, but what you really see on the front is you change some configuration, you applied the configuration in a fashion that makes sense, and then you get a feedback saying that, okay, now all the configurations are in the right place. So that's really what happened. So let me switch into some of the more advanced, or you can call it as new management operations that got added recently. So one of them is moving the master, this is something that you could have done with the API for a long time, because fundamentally speaking, moving master is what is happening under the cover. You really have to install the master node in some other host, then you make sure that has the correct configuration, then you stop this guy, you start that guy, and everybody should be happy. And then sometimes you have to restart all the, all the slaves so that they get whatever the configuration is needed. But ultimately, this is just trying to make it easier so that you can do it one stop. But the thing is, anytime you actually use this or any feature, I would actually suggest that you can look into the HTTP calls that are going from the front end to the back end. That really shows you the internals of what is going on. And rolling restart is something that we talked about, so I'll not go into that. So this is another capability, which is maintenance mode. So the idea is that, again, a lot of these capabilities come in from the perspective of you have a cluster and then you have the cluster running for like months and years. So obviously many things start becoming problem. That is not a problem if you just build a cluster, do some testing, do some experimentation, then you bring down the cluster. So with maintenance mode, it's actually fairly simple. What we are saying here is that I know, so the IT admin is essentially saying, I know that this host or this service is not in the healthy state. So I don't really want to be bothered with two things. One, I don't want alerts. The Nagios alerts are fairly notorious with respect to telling you that something is down, something is down. Or if I have stopped all the slave components on this host, like the data node or region server, and then somebody else is doing a start all or stop all or something like this rolling restart, I don't want this thing to be started accidentally. So these two capabilities are the ones that we have basically grouped together in maintenance mode. So essentially alerts will be stopped. And as far as this specific host and the components that are running on the host, or any specific service, let's say for whatever reason you want to disable Uzi momentarily because you are playing with some configurations, it will be invisible to the outside world with respect to more of the global operations. But you can actually go to that specific host or that specific service, and you can still do your operations same as if it is not in maintenance mode. So it's really a selective blindness, if you want to call. So that's maintenance mode. And bulk host operations, as you said, that so you essentially have many operations: start, stop, decommissioning, etc., etc. And the bulk host essentially allows you to apply the same operation on a setup host, and you still have the same capability of doing a phased application of operation through the host, like we did in the demo. So one of the final items on this particular piece is the blueprint. So the blueprint captures essentially a basic notion of you have a cluster that is up and running, it has configurations, it has all the mappings of, like the master here, slave there, and things like that. Can I export that detail? It's really exporting the detail of the cluster. And the idea is, if I can export it, then I should be able to import it later on an empty cluster, in the sense nothing is deployed, and I can simply replicate my cluster. So as you can see, the big advantages are for, let's say, testing or pre-production environments, etc. You probably won't really use Blueprint to create a production environment, but anything before that is all game as far as the Blueprint goes. So this is the capability that right now primarily is at the API level. But what you can do is you can essentially go to a cluster, and then you can say export the cluster out, and then you will get a JSON file, and you can go to another instance of Ambari server. So it is not a export in the sense of you export the whole thing out. You really export the agents and the mapping of the the stack components into different hosts as a blueprint. So all you do is you install Ambari server, and then you feed the blueprint to the Ambari server, and then it will create a cluster that looks very similar to what you had exported. So that's really Blueprint. Obviously, you can take it one step further if you have something else in the picture, where you can even, in your exported Blueprint, you can always add a section called, I want this version of Ambari server installed. And then something else can consume that, install Ambari server, and then have the Blueprint consumed by Ambari server. So in fact, that's kind of what happens on, there is an OpenStack project. I believe it's called Sahara, or it was called Savannah, and I think it's called Sahara now. So that's what they do, where you take the Blueprint, and then you apply a Blueprint to dynamically create clusters on demand. So that's really the idea. In their case, there is something else that is in the picture which actually installs Ambari server. And then after that, the Blueprint takes over. So essentially, the idea is that so the goal here is to go to a state where you can basically perform a zero-touch install. You don't have to click any buttons. You don't have to look through a wizard or a UI, and you can just dynamically provision the cluster based on some specification that you have. So like I said, so I want to spend some time on extensibility. So sorry. So the extensibility, actually, it manifests in various ways. But so one of the basic idea for extensibility is, so there is a stack definition that, let's say, Ambari is released with. But as you can imagine, there are multiple other services. Maybe there are variations of existing services that you want to add so that you can use the same Ambari infrastructure to basically deploy, manage, potentially monitor, manage the alerts. So essentially, as if that service got defined as part of Ambari from the get-go. So that's really the idea of extending a stack definition. So it helps both. It helps the dev team as well, because we do save a tremendous amount of time in terms of adding support for new services. And it does allow basically anybody else just to add some specific files and folders in a format so that you can add a new service. So that's really the idea of extending a stack. So what is going on here is fairly simple. So the stacks are essentially a bunch of files and folders that define the services that you have, the repositories. In fact, you can even include a tarball if you want, so it doesn't have to be a repository in a traditional sense. So now that is like the full stack. So now if you look into the stack, there is service definitions for HDFS, YARN, Uzi, etc. Now every service, actually, you can see them as a set of commands. So what really happens with any service? They have some components, so that as in I need to install a data node. So obviously the operations are install. Then I need to configure, so which is essentially how do I lay out my configuration file. It could be configuration file, or it could be actually a env.sh file that you need to modify by adding some extra parameters. And then all you do is you start, you stop, you may decommission, you may want to perform some check, or you may have some other operations that you want to perform. So those are essentially commands. So if you take them all together, you can actually create a package that declaratively define all of this. And that's really the premise behind extension. Now, there is the other side of the story is, obviously you cannot take arbitrary structure of how you want to extend, mostly because there is an agent that needs to understand what you have said. So that forces some sort of a grammar or some sort of a schema or some sort of a language constraint on it. But the great part is at least it divides up the details of Ambari and the details of stack. So they are divided as two separate things. So that's really the whole, the idea behind how you extend the stack. So now what happens after you have extended the stack? So essentially Ambari server comes up. It will read the stack definition. And that's where it basically performs the validation as needed that whether the stack definition looks correct. So now once the stack definition is understood, you get to the step where you are directly talking about commands. I want to install or I want to configure. The command is actually sent to the agent. The agents have actually two possibilities there. So one, agents are obviously always shipped with the definition that we already know, mostly to save time, but doesn't matter. If the agent does not have the definition or has a wrong hash of the definition, it will basically download the scripts and the XML, etc. from the server. And then now agent can execute the command. So, and if that means if stack definition actually changes, you do not have to restart Ambari server. You do not have to restart agent. So you can actually have the whole thing work out dynamically. So that's really what is going on under the cover. Now, I will just show you a little bit about what exactly a declarative definition consists of. So these are essentially some screenshots. So this is HBase. I mean, if you look into there, it will have a folder for configuration, which actually has the default configurations. Then you have a folder for package, which actually has a various number of scripts that implement various commands. And then there is a metadata file, as you can imagine, because somebody has to tell where what is and what other things are, what is the name and things like that. So now you look into the meta info, which has exactly the information. So there is a piece called HBase master, which is of type master, and then there is a script that has implementation of commands for that master. So now if you look into the packages folder, you will basically find scripts of this type. So essentially there is a script for master, there is a script for the slave, or as many components you have, you may actually have different scripts for each. Now, frankly speaking, you don't really need separate script. It is just something whoever developer wrote this decided to organize it them this way. But yeah, there is no real rules once you get inside the script how to do. So the only rule here is that there are some commands that are expected to be supported. So for example, commands like install, configure, start, stop, and I believe restart, where the default definition is called stop and start. They have to be supported so that it works well within the context of Ambari, but you can add custom commands if you want. So in fact, decommission gets added as a custom command. That's what we did. So what Ambari does is it allows for you to issue a command called decommission. It will simply take the string decommission and then send it to the agent. And the agent will pick out the Python script, will execute decommission. It doesn't know what happens after that, but something happened. So as you can see, that there is a slight difference here. So one is there are some commands that explicitly change state, as in if you do start and stop. So there is a little wire up to the overall server's view of what is going on in the world. There could be commands that don't change state. Let's say you want to issue a rebalance. I'm just picking some examples, in which case you can actually arbitrarily add any random commands you want. If it doesn't change state, it is great. But even if it changes states, all it will happen is that right now Ambari only understands start and stop. So it will find out that something has stopped or something has started. It will accurately reflect that. But if the state doesn't change, you can arbitrarily add commands. So that's really the crux of the declarative or a declarative way of adding services. Now, if you are adding services, if you're adding additional services to the picture, then there is an obvious need of adding views that can actually come up on Ambari server. So that UI, obviously, I mean, the backend server, we added the support for extension, so the front end didn't want to be left behind. So they also added the support for views. So in this case, what Ambari allows anybody to do is, can I add custom views that essentially can come up within the context of the Ambari web UI. And then they can do basically anything. They don't really have to work for the services that are ordered. Your view can do anything, obviously. And then you can do some additional capabilities, such as is the view, who can see the view, or which user has access to the view. So obviously it allows few additional capabilities of, okay, this view is need to be secure, or this view is read-only, that view actually has some editing capabilities, etc. So you can do all sorts of things. So this essentially this extension on the front-end side complements the extension that we have on the back-end side, as in the stack definition, but you can use it any which way it makes sense. So again, this flow is also very similar to what happens to the stack. So you have somebody who, again, there are APIs for it. There are certain, certain rules or certain requirements in terms of what you need to do. But what you do is you just create a view and you deploy the view to the Ambari servers. Essentially, deploy for views or stack basically translates to go to this folder and you drop your files, and at best modify some configurations. And then in view case, what happens is one of the admin user can actually create instances of the view. So that means, the view UI is not ready. So essentially, I have a mock-up here from our product management. But the idea is, once you create a view, you create instances of the view, and each instance can have their own configuration. So for example, my view is simply, let's say, I want to access the name node UI, but in a slightly more friendly fashion. Let's just say that. So in that case, you need which port number, etc. So these are the configuration that should go to the view. So once you create an instance of the view, you assign the configuration, and now what you can do is you can say who can access the view. So that's really the very high level, the security aspect of the view in terms of who can access it or who cannot access and things like that. And like I said, I mean, from a conceptual standpoint, the view is general purpose, so nothing really stops you from creating a view for weather. And if I remember correctly, I think the example that Ambari ships with is actually creating a weather something. If you want to see weather from the Ambari UI, you can feel free to do that. So that's really goes on, as far as the view is concerned. And then, like I said, you can customize the view in terms of who can access and what are the instances and the details, etc. So all in all, this complements the stack extension side pretty well. So the final part that I wanted to stress on was the integration part. So because, like I said, the goal for Ambari is, of course, to be able to do whatever is necessary to manage the stack, but also try to be as extensible as possible. So here is essentially a pretty high level, just three, not so much as examples, but three instances of how the extension works. So there is an extension from Teradata side, actually Ambari extension with Teradata. So what integration, what happens here is that Teradata uses Ambari APIs to access the metrics, essentially the ganglia metrics, the JMX, etc., of the cluster that is deployed. So basically the cluster gets deployed, but the Ambari server API is used to access the metrics and the monitoring data. So there is no management control as far as Ambari is concerned. There is no UI and there are no agents in this case. So this is really the server and the API infrastructure in the server getting used for integration, and that's pretty much it. So another integration that had happened was Ambari's integration with System Center. So it's a SCOM pack that got developed. So in this case, what happened was that, so there is Ambari server that is running, which knows of the cluster, and there is a pack that got developed, which is essentially a plugin to System Center, but it will talk to Ambari server in the back end, and it actually can perform some management operation in addition to showing all the monitoring and the metrics, etc. data. So this is essentially an integration with system center, and then this is just some screenshots from that. So in this integration, there are a few extra operations that is happening through Ambari, namely the management. In case of Teradata, the management was site. So essentially, you have a choice. And the final piece is something that I talked about a little earlier, especially when I was talking about Blueprint, which is a completely different class of integration. In this case, Ambari server is being used completely in the sense that there is a separate entity that installs Ambari server, then uses Ambari server to install the whole cluster. But in this case, the cluster is targeted towards basically VMs that you obtain from the OpenStack. So there is some other service that allows you to ask for VMs based on whatever resource requirements you may have, like 2 gig VM, 4 gig, or whatever else you need. And then it obtains all the VMs as needed, and then takes the blueprint, imports the blueprint, then imports a bunch of host groups. Because what really happens is after you get the VM, you basically got your host list. That's a host 1 to host 100. Now all you need to do is map it to whatever blueprint that got exported. So essentially, if your data node was mapped to, let's say, 5 hosts, then all you do is, okay, now it is mapped to host 7, host 9, and host 15 and 16 or something like that. But the whole blueprint feature gets used with the OpenStack integration. And then what you see here is essentially use Ambari to dynamically provision clusters using VMs that are coming out of some other service in OpenStack. So that's a third sample of integration. So that's pretty much what I had. And then these are some of the URLs. And 1.5.0 just actually got released a few days back. And yeah, it's like a regular Apache project. So feel free to create Jiras, contribute, anything, any which way you can add. So that's perfectly open. Yeah.
Which flavors of Linux this is supported, Ambari?
Ubuntu not yet, but we are targeting. I think it was a lot about testing and making sure that it actually supported. So Ubuntu support should coming in soon. But what do you call RHEL, CentOS, and SLES, SUSE, yeah.
Is there a possibility to have a log of all changes that were applied in the user interface by user, for example, to see if some configuration was wrong, who did it, to roll it back?
Yes. So as far as so the question was about whether do you have a log for all the configurations. So yes, every change that you make in the configuration, when you hit the button save, it gets saved as a new version. So you always have the older versions. So right now, there are APIs which will let you apply any older version to be my current version. There is no support in the front end for that, but yes, the answer, yeah, it's possible. You can do it. Yeah. Go ahead.
In the new service definition, I saw the XML that there was like script times Python.
Yeah.
Is there any other possibility?
Oh, yes. Right now we have support only for Python in the agent. Right now there are two types of scripts are supported, Python and Puppet. Puppet because we always had Puppet, so obviously that support exists. So whenever we added support for Python, we added the ability to flip between Python and Puppet. So again, fundamentally speaking, it's possible, but to do that, you need to make some changes in the agent code. So, but after that, you should be able to support any script.
The agent itself
Agent itself
is written.
is written in Python. Yeah. Sorry. Yeah.
You said at a certain point in the slides that you moved from Puppet to Python.
Yeah.
What motivated you?
So in our case, we were actually struggling a bit to add unit tests and essentially detailed unit tests for Puppet. Now, personally, I don't know how far that is possible or not possible. So that was one of the motivation to move to Python so that that whole thing is a lot easily testable. The second thing was that we were going through the refactoring of the whole scripting so that you can be more declarative in your stack definition. So at that point, Python seemed a lot easier in terms of how to structure and then how to do all the things. it was a lot easier to expect people to write Python. So that's really it was. But like I said, today Puppet support still exists, so we are not exactly deleting it. We just have to see whether we need to keep it or not. Oh yeah.
Possible to bring an already running cluster on the environment?
Yes, we have done that. The thing is there is no easy way to do it. But if you look at Ambari, so essentially you can, so there are a couple of ways to do it. I have seen what people do is they deploy a fake cluster and then looking very similar to the cluster you have. It doesn't have to be like if you have like 500 node cluster, you deploy 500 node, but essentially very similar to the services you have and some of the configurations that you apply. And then what they do is they go to the Ambari configuration and just edit the configuration out to point to the old location. So that's how you can have it manage a different cluster. So that's typically what I have seen. There is no other easy way to do it. It's not like there is an export and import. So there's one more question. Yeah.
Yeah, the question about the dashboard. I guess it stays being persistent to the local database.
Yes. Yeah.
Then Ganglia, you can multicast to a set of servers, I believe.
Yeah.
Okay, so the question then is, can you make the dashboard in a set state or set a persistent state to a single database and have multiple in Ambari?
Oh, you're talking about the metrics that gets
No, I mean, can you have multiple instances of Ambari, so having running on multiple servers, accessing the same data? Because they can share the same database.
Yeah, so multiple instances of Ambari server itself.
Yeah.
No, we haven't really tried that. But you should be able to log in from a different. So you can access the API from different places. So you should be able to have the. You should be able to log into the web UI from any places. Yeah. Yeah, in principle, yes. We just haven't. We just haven't thought about it. Yeah. Yeah. Sorry.
Is Ambari server able to monitor and manage multiple clusters, or do you need multiple instances?
Right now, it's multiple instances of Ambari. So one instance per cluster. Yeah. Oh, yeah.
How do you patch Ambari?
So if there is a new release of Ambari,
Every couple of weeks coming out something.
yeah. So you can perform like stop Ambari server, perform yum upgrade, and then you start Ambari server. That's typically enough for upgrading. One step I missed is you may have to run Ambari server upgrade, which changes this database schema if needed. So, but it's fairly, the upgrade path is fairly stable and it's fairly straightforward. It's really just 3-4 steps. You stop, yum upgrade, call Ambari server upgrade, and you start. Yeah, very rarely we have had to do anything more than that. Yeah. Okay.
That includes the agents.
Oh yeah, that includes the client as well. Yes. Yes. Okay. Thank you.